Okay, let's hit it. Hey, I'm Tim Abel. I have been a dev for the last 23 years and I'm here to share with you some stuff that I've learned about dependency injection in Rust. So I've been coding since, well, many years before I started coding commercially, but the year 2000 was when I really started commercially on ASP Classic websites for a university department. For commercially, I've done a lot of C#, also done Ruby on Rails, which was really interesting, which is kind of the polar opposite of Rust, being super dynamic. You really don't have to define anything, you don't have to think about how the machine works, it's quite expressive. So lately I've been getting into Rust. And I did the read the docs thing, did the tutorials, which is really cool, really well written. It's a nice on-ramp into Rust as a language. It's taught me some humble pie. I kind of assumed, having learnt a lot of languages over my years, that, picking up another language, well, how hard could it be? But actually, Rust has been a good challenge. The borrow checker has indeed been tricky to do. Having to think a bit more about references and pointers and stacks and heaps, that kind of thing, much more than I'm used to in doing kind of application level C# work. It's been a good challenge for me. But also, I bring the history of approaches from other languages. It's pretty common when you pick up a new language to try and write the new language the way you wrote the old language. So hopefully you don't all think this is that. Hopefully this is actually a useful technique, and my opinion is that it is, and that is a tool for the toolbox. So this is related to testing, because that's really the main reason that we want dependency injection. So I'm going to take you a little bit on the journey from when I started with Rust, which I've already started talking about, and into the project that I picked up, decided to create to help me learn, and the challenges inherent in building that project, and why that then led me into giving some proper thought to dependency injection and how that behaves in Rust. So let's go. So, gitopolis. I expect you've never heard of this before because I made the name up not that long ago. So I was working for a company, a client. It's actually a C# client, and on the side also learning Rust. Kind of got to a point, I read all the tutorials and I wanted a real thing. So because this client had microservices, many Git repositories to manage, keep up to date, see what state they're in, see what branch I'm in, see if I've forgotten to push anything. But primarily, like a real thing to get my teeth into Rust. So a nice sort of bite-sized project that I could pick up and do and learn some more lessons along the way beyond the tutorials. So I built it, and it's doing exactly what it says on the tin, which is to allow you to, for a set of folders with Git repositories in it, run a Git command, for example, or any other command across all of those repositories, clone from scratch if you've got a new team member or a new laptop that you're building or something like that. I ended up using it for real on this project, and it was actually super helpful. And because I wanted this to be like an open source thing, like a gift to the community, I have written this thing test driven, specifically because I want to be able to receive contributions back from the community and kind of know that this contribution hasn't broken what I've created. So for that I needed good regression tests. And we'll see how TDD, the test-driven approach, feeds into what I want to talk about, which is dependency injection. So this is kind of setting the scene for that. So that's all cool. I'll just show you a little bit more of this project just to give you a bit of context. So this is it up on GitHub. It's already got releases. It works. You can download the binaries for Windows and Linux currently. I'm no Mac person, but you could always build it yourself if you really want it. And this is it in action. So gitopolis is the binary. Exec is a subcommand of that binary. And in this case, that's got an argument. So I'm filtering what exec runs on to this particular tag. So that it's going to, out of all of the Git repositories it knows about, it's going to only run whatever command I give it on the ones that are tagged with Tim, which is kind of cool. You might have projects for your team, projects for other teams, so it allows you to cut that up any way you want. And then the dash, this is something that you might see in other systems as well. It's telling the argument parser that we've finished with the arguments to our commands, and you can just go and collect everything else up and do something else with it. So in this case, we're saying, right, everything after here, we're going to just run on all of the repos. And the reason that you need that dash is if you say, put an argument to git in there, so git -- help, for example, then the argument parser for gitopolis would end up being confused because it wouldn't know which is which. So you hit enter on that, and then it runs git status as you've asked it to on the first repo, which is the gitopolis repo, because I happen to have that under my Tim tag. Schema Explorer repo, which is a project I did previously in Golang. And you can see I'm all up to date, which is cool. So no one has contributed to that. And my blog, and again, no one else is going to be contributing to my blog, mostly, apart from maybe Dependabot. So you get the idea of that running. That's to see it as a real thing. So why dependency injection? Notifications. I should probably turn all of the other things off when I'm doing this kind of thing. So the test coverage that I've got in Gitopolis, got a few layers in a kind of testing pyramid. I do have the odd unit test in there for a little interesting piece. At the other extreme, I've got what you might call an integration or an end-to-end test. So that is made quite easy in Rust, which is nice, but it basically tests the real built binary, like fires actual commands at it, and that's really useful. So one of the things I'd managed to actually break was I did a refactor for that tag argument that we saw. Literally while I was building this talk, I ran the command to get the screenshot and realized that I'd renamed it in the code to tag name because it looked better in the code, but because of the argument parser is kind of inferred argument names based on the code, I'd accidentally changed the contract on the command line to be -- tag - name instead of just tag, which was redundant for the command line. So then I expanded out my regression tests for the command line. And if you want to see those, public Git repo, have a poke around in the end-to-end tests Rust file. Very cool. Really happy with those, and I've now got pretty good coverage of all of those. So if somebody submits a PR, I will be able to see very easily from the tests if they've changed the command line interface either intentionally or accidentally, rather than having to infer that from the definition of the arguments in the Rust structure, which is cool. So I didn't need any dependency injection for that, because that's testing the real binary, running on a real file system, calling out to a real Git binary. Cool. Where dependency injection comes in is the next layer down, because these end-to-end tests, they're a little bit slower, certainly in Rust kind of terms of speed. They're a little bit more cumbersome to write. If you're testing kind of many variations, it's going to get a little bit messy. And certainly I've seen, like, on a bigger scale project, a client who I won't talk names, but we went really hard on the component test idea for microservices. Really cool. Like you can, write your component test. You can test end to end that, like, yeah, this whole thing hangs together. You know, in C#, it's really quite common to have services like C# service classes dependency injected into the running thing, and it's such a common error to forget to wire up the actual startup server to inject those. So your tests have got a separate injection of those. Tests are all green, ship it, fails on production because you forgot to set up the dependency injection, which is frustrating. So by having these component tests that test are like a real web server running but in memory, you'll catch these sorts of things. So this is cool. But we saw real problems with how fast they ended up being, because we put a really heavy emphasis on component tests, and I like where it's coming from. Like being able to just completely rewrite the innards of your microservice and have your tests still be valid is cool. But over time, even with a lot of it being in memory, they still got slow as we built up more and more and more coverage. So I still believe that we should have the testing pyramid, and we should be thoughtful about like what we put at what layers of testing. It's a dogmatism. It's a, we don't want to run in absolutes. We want to engage our brains for each problem that we have to solve. So for gitopolis, I wanted to test that the kind of the engine part of it was behaving, but with a fake file system and a fake Git implementation. In terms of, this is what happens when I look at my slides ahead and realise that I've already talked about it. So I've talked about my regressions. So yeah, so test coverage, so I can accept pull requests, so that I can catch my own regressions, and this layer here that we were just talking about, everything but the disk. So I want to test that we are, excuse me a second. Joys of working at home. Someone's just home. Let me just make a quick message to make sure I don't get Kate crashed. Hopefully that will do that thing. Right, where was I? Testing everything but the disk. So in order to have the code be able to either, when you run the actual command, interact with the real file system and make calls out to the real get executable, and interact with the terminal in terms of inputs and outputs, but in tests be able to run very fast tests that I can abstract nicely, where I can see very quickly what kind of is run on the disk and what it hasn't. I needed to have this way of swapping out the code that was actually going to do that. So at this point, this makes me think about dependency injection. So from my work in C# and Ruby, this is a super common pattern to swap out pieces. In Ruby, this is like ridiculously easy because it's all dynamically typed. You don't even have to kind of declare, oh, this is the same thing. You just like put that in place, and Ruby will, as it executes, kind of just hope that works, and as long as you've implemented the same implicit contract, it'll work and it'll run your test code instead of your production code, and that's kind of all cool, albeit a little bit fragile, a little bit hard to deal with. I actually prefer the slightly more explicit interfaces in C#, which obviously Rust is much more like that. In C#, dependency injection is really common. Like if you don't take the component testing thing to the extreme, then it's still a really common pattern to have anything that's external to your thing mocks out. So you'll have your real implementation as like a C# class. You'll have a fake thing as a C# class, and you'll have an interface definition, which is a bit like traits in Rust, which declares the contract that they both have to fulfill. And then at test time, you'll inject the fake one, and when the real thing is running, like when your web server starts up, you'll inject the real one. So I looked at this and I was like, how do I do this in Rust? Because this seems to be the thing. And I tried a few approaches, which were of varying levels of yak shaving success and sort of cleanness in the kind of code that we ended up. And also there's kind of performance trade-offs which are interesting, and I'll try and talk intelligently about, although I'm a bit newer to the Rust thing. I'm totally not a performance optimization expert, particularly coming from kind of the application level. Like from my point of view in my world, generally, in terms of optimization, the code is generally not really the problem, apart from extreme loops and nested loops and that kind of thing. Really, it's like, oh, this thing's making 100 calls to the database over the wire, and therefore that's really kind of, that's what's killing my microservice or what have you. That's not to say that we shouldn't optimize code, but we have to take everything in proportion to what its actual impact is. So I'll start with where I ended up on testing, which is traits and using box to inject. I even have a slide titled this. So I'm going to fire off to the Agile repo and we can go look at some code. So let's go look at the tests. So I'll just back to what we were saying earlier. So here's the end-to-end tests. So we can say we're going to execute gitopolis in the temporary directory, and we are going to call the add argument with a Git folder that we have set up, and that setup is creating a real Git folder on a real temporary folder, which is obviously slower, but it's a much more thorough test that everything's behaving. We can check that the standard error comes out correctly, and then we are checking that Gitopolis' state file is in exactly the state we expected it to be, which is another piece of good coverage, because if anybody changes the behavior of this, interestingly, I upgraded the TOML library and it did subtly change the way this is formatted, and it was really good to be able to see how it had changed it, because I run the tests, I see the before and the after in the diff, and then check it in, and now you've got a patch that says upgrade the library, and look, this is exactly how it affects the config format, and that is a really good record of the changes. I definitely recommend that kind of thing. Anyway, back to the end up struggling with names for these things. The tests for the engine itself. So here we have a test for add at the next layer down. So at this point, you can see here we're creating a fake storage, and this one's got a callback, which I can go into a little bit, and a fake get, which we have to box, which I'll explain in a moment. And then the Gitopolis is kind of like the crate, the library, whatever you want to call it. And then we run the command. So this is below the layer of command line argument parsing and code, because there is, if I show you the actual code, I'm going to jump around a little bit here. We have, so this is the main like CLI. I think. Oh, am I in the wrong place? Oh, main. Sorry, yeah, I am in the wrong place. So the Gitopolis is the main logic. Main is the actual, what kind of defines the command line interface. So you can see here we've got an enum, and this gives you clap is command line argument parser. Very good library, very impressed, having used an absolute ton of command line parsing libraries in various languages. They're generally almost good. This is a really good one. I'm very impressed with it. So you can see that having defined the commands, when we receive one of these commands, we then map that to a Rust function, which this is actually just a little private function just to make it easier because we're going to loop. So then we grab the gitopolis library itself, instantiate that, and call the add method on it, and just check it didn't blow up. My Pomodoro's gone off. Where was I? So, where did I get to? So we're getting back to the tests at the next layer down. Right. So yeah, this is the one we're going to be testing. So here's the actual call to add. We can see when we are creating this, here's the actual dependency injection. So it is going to have a reference to storage and to Git, and where's the trait gone? Where did I define the traits? I don't know. Where's my scroll bar gone, more importantly? Don't know my own code base. It's not even been that long. It's amazing how quickly you forget. So implementing that. Let's go to storage. Oh yeah, it's the other way around, so the traits are here. So the way we create the abstraction that we can then inject the real one or the fake one is we create a trait, which this is our contract. We say, okay, what gitopolis needs out of storage is the ability to see if a file exists, which is just a Boolean response, to save a file, where you give it a string and say, hey, put that in your storage state file, and to read it back. So you just call read and say, okay, and that's my state coming back. That's literally all that this thing needs out of the storage side of it. I won't go to the Git side, but you get the kind of idea. Now, the trade-offs about this approach are basically, because we're using a trait, and we don't know what size it's going to be, because the fake one is going to have a different size on the stack than the real one. So this is the real one, because they might have different data. So this one needs a path. The fake one has callbacks. So if I can find the fake storage, I could use this new navigator thing. So here's, so fake storage needs to know different things because it needs to cache what was saved to it when it was faked, and I've got a callback thing so that you can test the behavior so you can check that it would call the save and that it had the right thing in it, which is cool. That took a bit of fiddling to get that to work and behave, but it's all there, it all works. Again, you can go and look in the repo if you want to see that for real. So yeah, back to the trade-offs. If we go back to storage. So the fact that we don't know the size of it, means it can't live on the stack, which is less efficient. So you end up with a pointer to the heap, which is what this dine implies, as in, like, we don't know, so therefore it needs to go on the heap and get the size allocated. And from what I've read, there are circumstances where you might not want to make that trade-off, because you are optimizing the hell out of your actual runtime, your real production code. And by introducing boxing, by putting stuff on the heap and having a pointer and having to dereference it, like, those are processor cycles that you just don't want to spend. So in that case, that would rule out this kind of dependency injection. But for an application like this, where it's an executable, you write a command, you run it, we're not going to run this over and over again, it's not a high volume web server, this is a perfectly reasonable trade-off to make. And because the code, as a result, is clean, easy to follow, and nice and flexible. This is for this particular system. This is a really good trade-off here. So I just go over kind of the overview of this to make sure that it's kind of clear what this approach is. So we've got we're testing the engine of this thing. We've got two ways of instantiating it. We've got in tests, and we've got for real when you run the command line executable, a binary. And then as it instantiates the main library, it injects into that the implementation of storage that is relevant, so either the fake one or the real one. So let's go see the actual injection, which is in it. It's just a little wrapper to make it easier. So we new up gitopolis, which is like the engine of this thing, and we box the implementation of storage, which is the real implementation, and this is the data that this needs, which is where do I find my actual file in order to read and write. And we also box up the real Git implementation, and that's how it's wired up in the real executable, so that when it runs and you run a command on it, gitopolis will say in its logic, oh, I need to write the state file. It will then delegate to this implementation, which, because this is the real one that's been injected, it will then write that to a real file on the real file system, and everything's good and it can be read back again, which is cool. And if we go over to the tests, then we will see that in an individual test, when we are newing up gitopolis, instead of injecting the real implementation, we're going to inject this fake storage thing that we created, and that needs different things. So that needs a saved file callback, but it doesn't need to know the location on disk, because it just keeps the text content in memory for later use, which is cool. So that's our dependency injection in action. So yeah, that's cool. There's some other ways of achieving this. I think, which, if you, for example, like I was saying, if you're like trying to optimize the hell out of some like hot path microservice, like say your front door router to like all of your stuff, you know, if you're writing a service for Cloudflare or something where you're like handling the entire world's traffic through a Raspberry Pi, I don't know what they use really. Then one of the approaches I came across was macros. So you use macros to generate the different code for runtime and test, and then there's no boxing, there's no abstracting out. It's literally just, it generates different code for each build. That to me seems more complicated to work with from a coding point of view, but if you need that last juice of speed, then that might be a sensible trade-off. And I am going to go and look at I'm going to pull up my terminal and drag it in so we can see it. Now, this is the first time I've done this talk, so I'm going to do some actual spelunking in my actual own history, because I tried a couple of different approaches and ended up with this approach that we see in front of us. This is TIG, by the way. I really like TIG as a history viewer for looking at diffs. It's a lot easier to get around than GitHub. It's a bit more expressive, and GitHub still doesn't show the trees, which is really annoying. I really wish they'd sort that out. So hopefully, if I get back in the history past where we were, so the recent history is getting the end-to-end test coverage in place, particularly after the regression I'd managed to introduce. Some updates to the libraries. The update to the TOML one was pretty challenging. I don't know if I'll be able to find this. This is where I'm not as prepared as I would like to be, and I will get more prepared over time, because I'm hoping to do this talk a few times. Upgrades, more tests. At first integration tests, so that's the end-to-end ones. First releases, so it was before, the experiments were before this. refactor. It's not just a refactor, is it? Implementing some features. So I've got CI set up. Yeah, I should show you that quickly because that's kind of cool. I just think it's incredible that for open source projects that we can have full end-to-end CI, like literally it's spinning up a Docker server with all the Rust tooling. It's actually running the build. It's actually running real end-to-end tests. So if I look at this last build of main and fire it up, you can see the test step literally doing a build right there in CI, and then they are end-to-end tests. So that is literally running the binary that it's built with the git command that's available with the real temp file system. Just amazing. That's free, and this is all in public, so if you wanted to go and look at the workflow files and see how that's done, then it's all there for you to see. So I'm still looking for when I flipped different. Right, so this is right back at the start. I don't know, I'm going to find this. Maybe it was in branches. So I've got an alias for the capital G, which will show me all branches that are hanging off this. Need to do a bit of a tidy up. Huh. Okay, I don't know. I'm going to give up on this because it's taking too long. So there was macros. In terms of other ways of doing this, which is a kind of a way of doing dependency injection, but the code compilation way. What was the other way? I'm sure there was one other way I tried. I can't remember off the top of my head. And the other thing I came across is there's a whole bunch of libraries that you can use, crates that you can find that help with dependency injection. I didn't use them. I saw a few of them because I wanted to see, as somebody who's like really getting into Rust kind of for the first time, I wanted to see how much can we do by just pure Rust code. I figured I'd learn more about the language by seeing like what I can create from nothing. So what I've ended up with the dependency injection in Gitopolis is perfectly good enough. It's really tidy and it's pure Rust. There's no library involved in this. There's no cleverness. There's no service library that we've pulled in like is quite common in C#. It's like pretty normal to have a thing that manages services. Like literally just a trait that defines the contract that needs to be available, a couple of implementations, and then just manually injecting them because there's only 2 dependencies, so it's not got too messy at this point to inject those when you're instantiating in these 2 places. So at this point, I am now confident that if somebody gives me a pull request, that I can validate that quickly. I've got the various layers of testing, which are easy to maintain, and I've got a tool that works, actually was really helpful for me in my time in the last contract. There's a bunch of microservices. I didn't have to install Python because Rust is amazing because it's all statically linked. So it just works, like literally just download the binary and it's good, and that binary is now available on GitHub Actions, so no different to pulling anyone else's public project. Just symlink it into bin or whatever, copy it into bin, which is really nice, makes it very easy. So that is where we're at for that. So any questions? That was me. There won't be any questions because I'm just recording. But by all means, drop me an email, catch me on Twitter. I'm at Tim_Able. The Rust Workshop is a software consultancy I'm working on. I've just set up a Discord server for the general community, so by all means shout and join us there. Should be kind of fun, like chatting around the stuff and hacking on things. Thank you ever so much for your time. Hopefully that was useful. See you soon.